Now, today we discuss about that Perkin condensation. This is a very, very important reaction. So, what are the reactant we are using in Perkin condensation? What are the reagents? Then, what is that final product? How to involve in the Perkin condensation? I will explain the total mechanism. So, here we are taking in this case. Here we are taking benzaldehyde, aromatic aldehyde with anhydride. You take any anhydride, but it should be having at least two alpha hydrogens. Two alpha hydrogens. But in this case, how many alpha hydrogens are there? Here, three alpha hydrogens are there. Then, in the presence of their salts, their salt means here we are taking acetic anhydride. So here we are taking sodium acetate or potassium acetate. So their salt, then which is converted to alpha beta unsaturated carboxylic acid. This is a CH double bond CH, C double bond OH. With respect to carboxylic acid, this is alpha and beta position. This is alpha comma beta unsaturated carboxylic acids. Carboxylic acid. Generally, this name is cinnamic acid. Cinnamic acid. So here, how to involve in the mechanism, I will explain. So it should be the condition. It should be we have to take first one is aromatic aldehyde. You take any aromatic aldehyde, then it should be having at least two alpha hydrogen, whatever that we are taking anhydride. Then we have to take the salt. Generally, it form alpha beta unsaturated carboxylic acids. How it is defined that alpha beta? Because of here, with respect to carboxylic acid, this is a carboxylic acid. With respect to carboxylic acid, adjacent position having that unsaturated group, that is a double bond at alpha position and beta position, double bond is present. So that alpha beta unsaturated carboxylic acid, this is we are calling as a cinnamic acid. So now I will explain the mechanism how to involve the reaction here. So we are taking first acetate acetic anhydride, then O, then C double bond O, CH3. Any electron withdrawing group, here this is electron withdrawing group, adjacent carbon always acting as a acidic carbon. If it is a next carbon is there, that next carbon is always neutral. So it should be that whatever that carbon which is directly attached to electron withdrawing group, that carbon is we are calling as acidic carbon. These are the hydrogens are acidic hydrogen. How many acidic hydrogens are there? Acidic hydrogens are three. Acidic hydrogens are three. Again, we are taking that is a strong base. What is that? Acetate ion. That is acetate ion O minus. So here first loss of H plus ion, loss of H plus. So here to observe the H plus ion. So then it forms CH2 minus, then C double bond O, then O, then C double bond O, then CH3 plus acetic acid. So acetate ion converted to acetic acid. So generally we wrote ACOH. ACOH means acetic acid. Here, whatever that we generated the carbanion, any condensation reaction, if they ask the question in condensation reaction, every condensation reaction carbanion as an intermediate. This one is to form the carbanion. Then again we are taking whatever that initial reactant, that is a benzaldehyde, that is here C double bond O. I will write H is here because for my convenient. So we wrote like this: C double bond O, C double bond O, O, C double bond O, CH3. Here this is a carbon and oxygen. Here oxygen is more electronegativity, here negative and positive. Always carbonyl compounds involving nucleophilic addition reaction, nucleophile attack to carbocation. Nucleophile attack to carbocation. So that here this is a CH minus, then CH2, then C double bond O, then C double bond O, here O, then here C double bond O, CH3. So here again here this is a carbonyl compound. This bond is moved to here. This one is a negative charge. This one is a positive charge. This is a negative charge attack to positive. It forms six-membered cyclic system. Six-membered cyclic system. Here C H, then here oxygen, then here this is a C O minus, then we wrote here CH3, then here O, then C double bond O, then in between CH2. This is a six-membered system. Then after that, which is involving again like here a resonance, this bond is moves to this direction, then this bond is moves to this direction. Is it clear? So it form like a state ion. Whenever it is bond is moves to this direction, this one get the positive double bond O. So that here we wrote here this is a C H O O. Here this is a C double bond O CH3. Then remaining part is a CH2, then C double bond O minus. C double bond O minus. So here one more hydrogen. So here one more hydrogen is there. So I will write here this hydrogen is the bottom. So for my convenient, here H. Then after that, we are taking acetate ion. Where is a acetic acid? Where is the source of acetic acid? From this one, from this acetic acid. So here which loses H plus ion, this H plus ion attack to O minus ion. So again, if acetate ion. Is it clear? So in this case, again here, this is here C H O C double bond O CH3, then CH H, then C double bond O OH. Then again heating. So here whenever it is loses like acetic acid here in the here which is more electronegativity carbon here this is oxygen is more electronegativity then it form acetic acid loss of acetic acid again it form this is so cinnamic acid CH double bond C double bond OH. This is a alpha beta unsaturated carboxylic acids. That is a cinnamic acid. First, it is we have to generate the carbanion. That carbanion always carbonyl compounds involving nucleophilic addition reactions. So this nucleophile attack to carbon, then this get the negative pi bond is moves towards oxygen. So positive and negative, this negative attack here again, which is involving lights. So I'm given one more question. This is a aldehyde. This is also aromatic aldehyde with acetic anhydride. The simple shortcut method I will explain here just for trick. So generally, so COONA. The trick is loss of H2O adjacent. It should be alpha carbon. This water you have to do that hydrolysis. Hydrolysis. OH is here, H is here. That is a final product. That is a final product. Then here CH double bond CH C double bond OH. This is a trick. Loss of water, whatever that loss of water, you have to do that hydrolysis. We get the final product. So this is a Perkin condensation.